Assalamu alaikum students. Good evening to everyone. I hope I am audible to you all. Can you see the slide? Uh, So today we have two important announcements. One regarding your final exam, and I have given a clear announcement regarding the final exam. So it is going to start from next week. Okay. So today will be your last session for this summer semester, and we are going to complete the syllabus. And I hope you all know that last week, I mean, in the last session, I told that one module will be recorded and given to you all. So I have posted the recordings in your message box. I think many of you, I mean, not yet seen the message. So please make sure that you access the recording for module 12 through the link that is provided in your message box. And also regarding the assignment too. So I think today is the due date for your assignment. So please make sure that you all submit your assignment. Um, I mean, those who are not yet submitted, to submit by end of today, so that I will grade and publish your marks by tomorrow. Okay, because I can see that still 7 or 6 students yet to submit. So I request each one of you to submit without fail by end of today, because today is the due date. That is one thing. And second thing, yeah, today we are going to have like this is the last module. Okay, so please follow the instructions that are given in the announcement regarding the final exam, and also make sure that you start preparing for your final exam. And at the end of the session, there will be another announcement that I will talk later. Okay. So now, without further delay, let us start our today's session, where we are going to learn about the topics related to the Internet Security Protocol and the Internet authentication mechanisms and all. So here we have two different concepts. One is related to the internet security protocols, and the second thing is internet authentication mechanisms. So now the first concept that we are going to start with, the internet security protocols. And it is very important with the email security. Okay, so here if you see the secure multi-purpose internet mail extension. So first understand what is MIME, multi-purpose internet mail extension. So the MIME is an extension for RFC 822, which defines the format of internet email messages. So the RFC 822, which is a basic email format, it is going to define the simple email structure like to, from, subject, like that. But the limitations of RFC 822, if you see, it supported only the ASCII character set, means it could not handle non-English text, attachments, all these things. Now, the MIME enhanced the basic email formatting by adding a new header field and defining the information about the message body. Because the MIME supports text in different character set, attachments like audio, video, images, application programs, everything. Now, when coming to this secure multi-purpose internet mail extension, its purpose is to enhance the security of the existing multipurpose internet mail extension, and it is purely based on RSA data security technology. So, the secure multipurpose internet mail extension provides the digital signature where it can ensure the sender authenticity, message integrity, and it can ensure the confidentiality only to the intended recipient that can read the message. So the MIME extends the RFC 822 email format by supporting multiple data types and attachments, while secure MIME enhance the MIME by providing the security features like digital signature and encryption based on RSA technology. So here we have like envelope data, signed data, clear signed data, signed envelope data, likewise. So the secure MIME define the contents like the envelope data. Envelope data means the message is going to be encrypted along with the necessary key. So the key idea of this one is message will be encrypted. The keys are going to be included for the recipient access. And then signed data. See the signed data, which means the message includes a digital signature to verify the authenticity. So here the key thing is that it is going to add the hashing function, the hash of the message to create. The hash is encrypted using the sender's private key, and it is going to provide the authentication as well as the integrity. Authentication as well as the integrity. So the clear signed data, which means the message is not encrypted, but a signature will be attached. So the key idea of this one is the message is readable, clear text, where the signature ensure the integrity and the authenticity. Integrity and authenticity. And the signed and envelope data. So the signed and envelope data, which means the message is both signed and encrypted. See, the enveloped data is going to encrypt the content with associated key. The signed data is going to have the digital signature using the sender private key. And the cleared signed data is going to have the clear text message with encoded signed digits. And the signed and enveloped data, this is going to have the combination of nested signing and encryption mechanism. Like for example, in our university, all official results are going to be like the signed data, and the general announcements are going to be like clear signed data likewise. So the secure MIME concept support multiple content types, including the enveloped data, encryption, signed data, digital signature, clear signed data, readable message with signature, and signed and enveloped data. That is the combination of encryption and signature. This will be enabling different levels of email security, different levels of email security. And then we have the mechanism, which is a standard that is used for the email communication. So it is built on top of the MIME multipurpose internet mail extension, and it uses the cryptography, that is RSA, AES or hashing, whereas it is going to provide the confidentiality, integrity and the authentication. So here there are various steps that we are going to handle for the purpose of secure MIME. First, the message creation where the sender will write the email. After that, the hashing, that is message will be hashed using SHA-256, and then the digital signature will be there. So it is going to be the hash that is encrypted using sender private key, and then here itself this is going to create the digital signature. Then the session key generation, so that is a random symmetric key which is generated, for example AES, this type of things. And the encrypt message, which is going to have the message along with the signature encrypted using AES. And the encrypt session key, which is the session key encrypted using the receiver's public key. And the send email is the last step, that is going to contain the encrypted message along with the encrypted session key. In the same way, on the decryption side also, it is going to have the same procedure to handle the process. So the signed and clear signed data. So first, what is signed data? See, the message is digitally signed using the sender private key, and it is going to ensure the integrity, that is the message not modified. Authentication, that is the sender is genuine. Then what is clear signed data? See, the message remains readable, that is the plain text, whereas a digital signature is attached separately and there is no encryption of the message itself. It will be used when the confidentiality is not required. Only the authentication along with the integrity are required. And in this signing procedure, first the message digest will be created. So that means the message is converted into a fixed length hashing 256 bit. It will be using SHA-256. So the digest is unique to the message. Any small change will completely different with the hash. And then the digital signature creation will be there. So the 256-bit digest is encrypted using the RSA that will be using the sender's private key. So the result is going to become the digital signature and then attach the signature. So signature is attached to the message. So the message may remain encrypted, I mean signed data or plain text, which will be having a clear signed data and the verification by receiver. So the receiver is going to perform recalculating the hash from receiver message, decrypt the signature using the sender public key, and compare both the hashes. If they are equal, the message is authentic, message is unchanged, like this. So next we have the enveloped data. See, just now we have seen about the digital signatures which ensure the integrity and the authentication. So here the enveloped data in Secure MIME is going to focus on how the encryption is used to provide confidentiality in email communication. So the main goal here is envelope data means the message is encrypted along with an encrypted key. So an encrypted message where the encryption key is also securely encrypted, and it is going to send with it, and here we may use the key idea of hybrid encryption. That means the message encryption along with the key also encrypted. So first we will generate the session key and then encrypt the message. After that, encrypt the session key. Then we will send the data. Then if it requires, we will recover the session key. Likewise, finally we will decrypt the message at the end user. So with all this, the envelope data in Secure MIME uses a pseudo-random session key to encrypt the message using AES, and this session key is encrypted using the recipient's public RSA key. So the receiver uses their private key to recover the session key and then decrypt the message, ensuring the secure and efficient communication. So with all this, the domain key identified mail is also going to play a very important role, because this one is going to focus on authenticating the sending of domain of an email. So here it allows a domain to take the responsibility for an email message by adding a cryptographic signature. So that means it helps receiving the system to verify that the message was not altered and genuinely it come from the claimed domain, making it a key technology in preventing the email spoofing and the phishing attack and all. So this is an example of deployment. And now let us see the secure socket layer. See the secure socket layer, or you can call it as TLS, transport layer security also. So this one is mainly focusing on securing the communication over the networks. I mean, like in the internet and all. So the SSL or TLS is a protocol that secure the data transmission between two systems over a network. Between two systems over a network. So when you look at the evolution of SSL to the TLS, where we have various versions. So the SSL version 1 and version 2 are the earlier versions, and SSL version 3 is the improved version with the public input, and then the TLS is the standardized version that we are using now. So the TLS is used instead of SSL in most of the cases. So here we will have the connection establishment, then handshake, then secure channel. After that, we will use the TCP. I mean, the SSL uses the TCP to provide a reliable end-to-end service. So the TCP ensures reliable delivery, ordered packets, then SSL or TLS will work on top of the TCP. So we have the transparent applications, like security happens below the application layer. and the application do not need to change. So embedding in applications will be like uh, built into specific software like web browsers, the HTTPS, and all these things. So the SSL was initially developed by Netscape to to secure the internet communications. Over the time, it evolved into the TLS, which became the standard protocol for providing a secure, reliable, and encrypted communication over the TCP network. And it will be creating the foundation of modern web security and all. And then the concepts. See, the TLS session is a long-term relationship that store the security, that is going to store the security parameters between the client and the server. So in a TLS session, first we will create, it will be created using the Handshake protocol. It is going to store the encryption algorithm, the key, and the security parameters, and it is going to help to avoid the repeating of expensive setup. Okay, so on other hand, we have the TLS connection. So a TLS connection is a transport level connection, and it is a temporary secure communication channel between the client and the server. So the TLS connection is like a peer-to-peer communication. It is a short-term communication, and then it uses the session parameters, and each connection will belong to a session. It will belong to a session. So the TLS session is like a long-lived association between the client and server that is established through the handshake protocol, which initialize the cryptographic parameters, while the TLS connection is a transient peer-to-peer transport channel that use the session's parameter for the secure communication, And then we have a very important concept that is called change Cipher Spec protocol and the alert protocol, sorry. See, these both protocols use the TLS record protocol, and it will change the Cipher Spec, which is the simplest protocol, and the alert protocol is used to report the errors and warnings, all these things. So the change Cipher Spec protocol is one of the 4 TLS specific protocols, and the key characteristics of this protocol, if you see, it is a very simple protocol. It consists of a single message, single byte. I mean, the value equals 1. So the main purpose of this protocol is to copy the pending state into the current state, like it activates new security parameters, new chipper suite. So it is going to result that it is going to update the chipper suite in a user usage. After that, the second one is alert protocol. So this protocol is used to convey the TLS alert to the peer entity, and the message properties are going to have like compressed and encrypted, and each message will contain 2 bytes. So the first byte, that is the severity level, either warning or fatal, and the second byte is the alert code, which indicates a specific type of alert, and then the fatal alert behavior. If the alert is fatal, the TLS immediately terminates the connection. So the other connections in the same session will be there. It may continue. There is no new connection allowed in that. So the change Cipher Spec protocol is going to be a simple TLS protocol which activates the new chipper settings using a single byte message, while on other hand, the alert protocol communicates warnings and fatal errors using 2-byte messages, where the fatal alerts terminate the TLS connection and all. And then we have the handshake protocol. Handshake protocol. See, the Handshake protocol is one of the four TLS specific protocols. It operates using the TLS record protocol. And again, for this, if you see the key characteristics are it considered as a simple one and it uses the single message, single byte, the value equals one. And the main purpose of this handshake protocol is to copy the pending state into the current state. So this process activates the new security settings and it apply negotiated parameters. So it is going to update the chipper suite in use. Okay. So the TLS handshake protocol is like a simple protocol that uses a single byte message to copy the pending security state into the current state. Therefore, thereby it is going to updating the chipper suite usage. After that, we have the heartbeat protocol. Heartbeat protocol. So, heartbeat protocol is a periodic signal generated by hardware or the software. So it indicates normal operation or the synchronization between the system components. So it is used to monitor the availability of a protocol entity. In simple terms, I can say that it check if other side is still active or not. So it is defined in RFC 6250 in 2012. So it run on top of TLS record protocol because it established during the phase one of the handshake protocol, each peer must indicate whether it support the heartbeats. Both sides will agree before using it. So it assure the sender that the recipient is still alive, whereas it is going to generate the activity during the ideal period, and it is going to prevent the connection timeout, inactive sessions, all these things. And then the TLS heartbeat protocol is a mechanism that is defined in RFC 62450 that send the periodic signal to verify that a peer is still active and maintain connection activity during the ideal periods operating over the TLS record protocol. And then we have very important protocol that is used in our day-to-day life, that is HTTPS protocol. So this is a combination of HTTP and SSL, and it is going to provide a secure communication between the web browser and the web server. So the main purpose of this one is to protect the data confidentiality, data integrity, user authentication. So the HTTPS is a part of all the modern web browsers. So the HTTPS is not supported by search engines, and the standard is RFC 2812, which is HTTP over TLS, because the agent acting as the HTTP client also act as the TLS client. So in overall, if you see the HTTPS hypertext transfer protocols secure is a secure communication protocol that combine HTTP with SSL or TLS that enable the encrypted communication between a web browser and a web server, where the client also act as a TLS client, and the connection termination requires the closing of both the TLS and underlying TCP connections and all TCP connections and all. So then we have the IP security. See, the IPsec is a network layer security mechanism. It is a network layer security mechanism. It is mainly designed to provide authentication and encryption. So there are many application level security mechanisms like Secure MIME, PGP, Kerberos, SSL, HTTP, all these things. So the security exists at different protocol layers, but the result is not all the applications are protected uniformly. So for that we have this solution IPsec idea. So it is implemented with the security at the network layer so that all applications are automatically protected. So the IPsec will provide authentication and then the encryption. So the IPsec features are included in the next generation IPv6 and IPv4 support the it can also be used in existing IPv4 networks, and the IPsec is a network layer security mechanism that provide authentication and encryption for all the network traffic, addressing security concerns across the protocol layers, and being natively supported in IPv6, while it is also usable in IPv4. So here the IPsec provides several advantages when implemented at the network layer. So the key advantage is strong security for all network traffic, whereas it is going to provide the strong security when implemented in firewall, router, all these things. So the thing is that it protects all the incoming and outgoing traffic, and it is not limited to the specific application. It is difficult to bypass when implemented in a firewall, and it operates below the transport layer where the users are not aware of IPsec operations, and mainly it can provide the security at the user level so that network routing mechanisms can be handled effectively. So with all these advantages, it can safeguard the network routing architecture. So now what is the scope of IPsec? See, the IPsec defines the scope of security service that provided at the network layer, right? So it combined with the authentication and encryption. It is combined with the authentication and encryption. So it is encapsulating the security payload. It is encapsulating the security payload. The purpose is to provide the authentication and encryption. So the key exchange function is used to exchange the cryptographic keys because it enable the secure communication setup, and also the authentication only function will be implemented using the authentication header because it provide the authentication only but no encryption. And then the VPN requires both authentication and encryption, therefore the ESP is typically used in these cases and all. See, the IPsec is providing the security. IPsec is providing the security through two main mechanisms: encapsulating the security payload ESP for combined authentication and encryption, and also authentication header for authentication only, with VPN typically requiring ESP, while the overall specification is complex and defined across multiple RFCs. So a security association is a one-way relationship between a sender and a receiver. So the purpose is it is going to provide the security for traffic flow. So the one-way nature, if you see, the security association is unidirectional, which means, let me show you the diagram. Yeah, one security association equals one direction of communication. So when you have two-way communication, for secure communication in both directions, we require two security associations. So the identification of security association is uniquely identified by the destination address, by the security parameter index, and the characteristics. And the security parameter index is a unique identifier for the SA, where the IP destination address is going to identify the receiving system, and the protocol identifier is going to indicate which protocol is used. AH for Authentication Header, ESP for Encapsulating the Security Payload, likewise. So in overall, a security association in IPsec is a one-way relationship that provides the security for traffic flow uniquely identified by the destination address and SPI, and the characterized by the SPI, which is having the IP destination address and the protocol identifier with two associations required for the bidirectional communication and all. And then the ESP mode for usage, the ESP mode for usage. So here we have two modes. One is the transport mode and another one is the tunnel mode. So the ESP, which is the encapsulation security payload, which is having the operation in two modes. One is the transport mode, another one is tunnel mode. In the transport mode, it extends the payload of an IP packet. So typically it is used for end-to-end communication between the two hosts. So the ESP is going to protect by encrypting the IP payload, optionally authenticate the payload, and it does not protect the IP header. And in the tunnel mode, it is going to provide the protection to the entire IP packet where it is used when one or both ends are security gateways. So the ESP is having the encryption, that is entire original IP packet, whereas it is going to add a new outer header and the original packet travel through the secure tunnel and all. So in overall, the ESP operates in these two modes. One is the transport mode, which encrypt and optionally authenticate only the IP payload for end-to-end host communication, and the tunnel mode, which protect the entire IP packet, and it is typically used between the security gateway so that it will enable the secure communication even for the host behind the firewalls. So now we are entering into a new topic, that is internet authentication. So here we are going to start with the introduction for internet authentication, and then we will see various topics that involved in it. So here, internet authentication, which is the function that are developed to support the application level authentication as well as the digital signatures. So the main purpose of this one is to verify the identity of users or the applications, and also to ensure the secure communication by supporting the trusted digital interactions. So here the main services it include the Kerberos, that means private key authentication. So it uses the private key, that is symmetric cryptography, and it provides a centralized authentication. And the second service is X.509, that is a public key directory authentication. It uses the public key cryptography based on the directory service. And then the public key infrastructure, it is going to provide the framework for managing the certificates, and it includes the creation, distribution, and revocation of the certificates and all. And then fourth one, that is federated identity management. So whereas it is going to use the common identity system across the organizations, so that means it is going to enable the identity sharing across the multiple systems. See, importantly, the internet authentication functions are mainly designed um, to support the application level authentication and digital signatures. So in that, the first thing we have the Kerberos. I think we have over, yeah, here it is. See, the internet authentication, as we know, the internet authentication functions are developed to support the application level authentication and the digital signatures. So these services will ensure that the user and the system can verify identities securely over the internet. So the main authentication service, that is Kerberos, which is a basic third-party authentication scheme. And it mainly uses a trusted central server, as you can see in the picture, to verify the users, and it is designed for secure authentication in distributed networks. So the key components here, if you see, one is authentication server, AS. So it is the first point of contact for the user. So the user initially communicate with AS to prove the identity, and the AS is going to verify the user credentials, and then the ticket granting ticket, TGT. So it is issued by the authentication server, so that there will be a secure forgeable authentication credential, and it is used to request further services without re-entering the password. So the ticket granting server, TGS, is going to receive the request from users based on the TGT. It is going to provide the access to the different network services, whereas it is going to issue the service ticket. And the Kerberos authentication flow is like this. User logs in and send the request to AS. AS will verify the identity and issue the TGT. After that, the user will send the TGT to TGS to request a service. Now the TGS will issue a service ticket. Finally, the user use the service ticket to access the required services. See, the key thing here is user do not need to trust all the machines in the network. Instead, they only trust the central Kerberos server. So the Kerberos is a centralized um, authentication system where a user first obtain the ticket granting ticket from an authentication server, and then they use it to request the service access from a ticket granting server without re-authentication. So if you see the Kerberos real life implementations. The Kerberos realm is, I mean, the service areas. So a realm is a Kerberos administrative domain. A realm is a Kerberos administrative domain. What it is going to have, it consists of Kerberos server, user client, users, I mean the clients, and then the application or the service server, application of the service server. So in large systems, there can be multiple realms. So each realm operates independently, but they can interconnect. So the Kerberos are going to serve in each uh, realme that may share a secret key with the servers in other realms, so be registered with each other. So then we have the trust relationship here. So for communication between the realms, one realm must trust the Kerberos server in the other realm. This trust will enable, and then with that, secure authentication across the domain and access to the service in other realm is possible. So remember, a Kerberos realm is an administrative domain, and multiple realms can interoperate by sharing a secret key, by sharing a secret key, and establish the trust between their Kerberos server for cross-realm authentication. So then the Kerberos version 5, Kerberos version 5 we have. See, in background, if you look at the Kerberos version 4 is developed in 1980s, and it is widely used initially. But the Kerberos version 5 was developed in the mid 1990s, and it is standardized with the RFC 1510. So why the version 5? See, it introduced to overcome the limitations of version 4, where it is provide a better flexibility, improved security, and the enhanced scalability. So the key improvements in Kerberos version 5, if you see, it supports multiple encryption algorithms. It is not limited to DES as it is in version 4. And also it use an encryption algorithm tag to select the algorithm, so that it can support different network protocols, byte ordering formats. So it is flexible with the ticket lifetime management, and it improve the security and usability so that it allow a client to access a server, let that server access another server on behalf of the client. So it improved with the cross realm support, and also it required fewer secure exchanges compared to the version 4. But there are many issues addressed from the version 4, like double encryption issue, non-standard encryption mode issue, weak session key handling issue, and then vulnerability to the password attack issue, all these things. So the Kerberos version 5 improved upon the version 4 by introducing the flexible encryption, better network support, enhanced inter-realm authentication, and they fixed for the earlier security and technical limitations also. And then we have the core concept, that is certificate authorities. See, a certificate is a digital certificate that contains the public key that and also the user identity. So it is the digitally signed by a trusted third party. So a trusted third party in the system, usually like government organization or a bank or a trusted institution like this. So they are responsible for issuing the certificate, signal signing the certificate, and establishing the trust. So the certificate creation process, if you see, there are certain key steps that involved here. So before that, in simple way, if you understand, first the user will create the public key and private key, then the user prepare an unsigned certificate, then user send it to the certificate authority, then certificate authority will perform like to create a hash of the certificate, encrypting the hash function, hash key using the certificate authority's private key, and then authority will attach this signature to the certificate, and they will return the signed certificate. These are all the key things that happen. So remember, a certificate authority is going to be the trusted third party that issue the digital sign certificates along allowing the others to verify the authenticity of a user public key. So there are core steps that involved in this process. So in the phase one, key generation and certificate request, first the user software creates private key and public key. The client will prepare an unsigned certificate, which includes user ID, public key, and the user will send the unsigned certificate to the certificate authority. So then the certificate signing will create a digital signature where they will generate a hash, that is message digest of the certificate, and they will encrypt the hash using this certificate authority's private key. And also the certificate authority will attach the signature to the certificate. Now it becomes a signed digital certificate. So the CA will return the signed certificate to that client. So in overall, as I said, the digital certificate is created by generating the keys, signing the certificate using CA's private key, and verified by comparing the hashed using the CA's public key. And then we have another mechanism, that is X.509 authentication service. So here the X.509 is a standard for the public key certificates, and this one is specified in RFC 5280. This is universally accepted format for the digital certificates. So the main purpose of this one is to provide the authentication, digital signature, and the secure communication. So it defines the certificate structure, and also it create the fields like public key, user ID, CA signature. So based on the public key cryptography, the digital signatures, it is widely used in many security applications like IP security, secure socket layer, secure electronic transactions, then secure email, e-business application. So it is a part of X.500 directory service standards, and it works with the certificate authorities and also the public key infrastructure. So the cryptography will be used by using the public key cryptography, digital signature, and the algorithms are not strictly fixed. So the RSA is commonly recommended. So the thing is X.509, which is a universally, which is um, a universally accepted standard for the public key certificates which enable the authentication and secure communication. So now we have the certificate variations. See, the digital certificates can be classified based on their validity period as well as based on their usage. Number one category, that is conventional, that is long live certificate. So that means it include the CA certificate and also end user certificate. So the validity will be like issued for months to years. So the characteristic, if you see, it is widely trusted. So it is issued by the recognized certificate authorities and it is used in the common applications, the SSL, email, etc. So the short-lived certificates are used for the temporary authentication, the applications like grid computing, the validity that is hours to days, and the advantage is to reduce the risk if it is compromised, misused, in limited due to short lifetime, then less overhead will be avoiding some management complexity of long-lived certificates. So the limitations are there. So the verification issues, like it may not be trusted outside the issuing organization. Reason because it is often not issued by widely recognized CAs. So the certificate variations include long live certificate that is used for general trusted applications and short-lived certificates used for temporary authentication with reduced risk but not limited to the trust. So another two things we have, that is proxy certificates and attribute certificates. See, the proxy certificates, which is mentioned as RFC 3820, this one is used for authentication. This one is used for authentication in um, distributed systems, then for overcoming of limitations of the short-lived certificate. So the key thing here is it is identified by the presence of a proxy certificate extension, and the capabilities are like it allow an end user certificate to sign another certificate, whereas it is going to support the delegation of rights. The main purpose is to enable the user to create the temporary credentials and to access the resources without exposing the full original certificate. So the attribute certificate RFC 5755 is used for the authorization and access control. And the thing is, the link like user identity, where it can have the set of attributes. So the attributes may include the role, permission, access right, other user related information, all these things. So the proxy certificate enable the delegated authentication by allowing the user to create the temporary credentials, while the attribute certificate associate users with roles and permissions for authorization and access. Now we have the public key infrastructure. So the public key infrastructure is a system that include hardware, software, people, policies, procedures, and this one is used widely to create, manage, store, then distribute and also revoke the digital certificate. So it is based on the asymmetric cryptography, that is the public key cryptography, because the main purpose of this one is to enable the secure communication, trusted exchange of public key, authentication of users and systems, and also it is clearly designed to make sure the secure, convenient and efficient public key management. And also the trust store is a list of trusted certificate authorities which contain their public key. So when a certificate is received, the system will check if the issuing CA is in the trust store. If CA is trusted, the certificate is accepted. If not, the certificate is rejected. So the public key infrastructure is a framework of technology, policies, and procedures that will manage the digital certificates and enable the secure trusted exchange of public key using asymmetric cryptography. And then we have federated identity management. So here let me show you the architecture. Yeah, so it is a common identity management system which is used across multiple organizations, I mean enterprises, multiple applications, because it support thousands or even millions of users. So the main purpose of this one is to enable the system for single identity across different systems, seamless access to the multiple services, and to reduce the need for multiple logins. So the main principal element here is authentication, authorization, accounting, provisioning, workflow automation. So these five are very important. See, authentication, that means it verify the identity of the user. Authorization, it is going to determine what the user is allowed to access. Accounting, where it is going to track the user activities, resource usage, all these things. And provisioning, where it is going to manage the creation of user accounts, access to the right assignment, and the workflow automation, like it automates the identity related process, access the approvals and updates, all these things. So the federated identity management will enable the user to access like this multiple systems across different organizations that will be using a single identity, supporting the authentication and authorization for the centralized identity services and all. And then we are going to use four different standards in all these cases. Four different standards that are going to be used. So it starts with extensible markup language. Extensible markup language, in short form we call it as XML, and this one is used to structure and describe the data, because this one define the appearance, function, meaning, context of data, and it is widely used in web services, even in the data exchange and all. After that, simple object access protocol, which is a protocol that is used for invoking the service over a network, that is used for XML over HTTP, and it enable the communication between different systems or applications. So the WS security is going to be a set of extensions to the SOAP, and it is going to provide the message integrity, the data which not altered, confidentiality, that is the data protection, and it is used in secure web service communication. So security assertion markup language, SAML, which is an XML based language, and it is used for exchange of authentication and authorization data, so that it works between the identity that providers, IDP, service providers, SP, and it is like commonly used in single sign-on communication. So all these are going to facilitate the exchange of authentication and authorization information between the systems. So with this, we have completed um, the module successfully. So, and this is also the last module for this course. So there is no next session for you all, because we have completed the syllabus. And students, my best wishes to you all. Please start studying for your final exam. I have given a very clear announcement regarding your final exam. So those who are not yet seen, please make sure that you visit the announcement that is given in the blackboard and read all the guidelines or instructions that I have given there. And I think this exam is going to happen on Tuesday, 18th of August, from 3 p.m. to 5 p.m. Okay, so my best wishes to you all. Do well. And one more important announcement before I am going to conclude today's lecture. I want to take a few more moments to share something that important with you all. So today is not only the end of the course, it is also my final session for you all, and also the final session at SEU, um, because I'm going to stop my journey after 11 years of journey with SEU. So I feel truly proud when I see all of you had a good progress, and I'm confident that you're all going to have a bright future ahead. And inshallah, you all will achieve a very great success in your career, and you're going to make your family and your friends proud, and also make sure that uh, like if you need any support, like a recommendation letter for your higher studies or any positions, so don't hesitate to contact me. Anyway, I'm going to give my email here. so that you can write a email if you want like any recommendation or any support regarding your career, I mean masters and all. So I am ready to help you all. Okay, so once again I wish you all the success um, and happiness and have a bright future. Okay, so my best wishes and my prayers to you all for your success and your exams. So do well and score good marks. Okay, so if you have any queries, please feel free to ask. Um, or else the attendance for today's session is recorded. You're all free to leave. And thank you so much for being this in this course. And I think some of you are already studied some other courses with me in previous semesters. And I really feel proud to teach you all, and also my best wishes to you all. Okay. So thank you so much. Have a good day.